Hi everyone. In this video I'm going to talk about selection sort algorithm, and for the video demonstration purpose I have the implementation of selection sort in Java. The concepts are same. You could use the implementation that I'm going to describe and implement this algorithm in any programming language of your preference. Understanding sorting algorithm is important if you are someone who is preparing for a software engineering interview, or even the interviewer, or just trying to understand the CS computer science fundamentals. It is important to understand these basic sorting algorithms, and it is important to know that what is the time complexity and space complexity associated with any sorting algorithm. So in this video I'm going to touch on those points so that you get the information uh, in terms of the details for sorting algorithm. So let me jump right into the implementation that I have for today's video. So here I am just defining an array. The array that I have is only having four elements, and all of the elements are in unsorted manner. So this is the worst case for selection sort. And here I'm calling selection sort. I do have couple of variables like time complexity and number of swaps to check that how many times the transactions would run, and how many times the method that I have implemented would do the swaps. So let me first run it. So this is the result. I have the sorted array, which is good. The time complexity is 10. Usually the average and the worst case performance and the best case performance of selection sort in theoretical text, you would see people calling it as O(n) square. So it is round about n square. And then the number of swaps variable that I have, it only does two swaps, so which is fantastic. It is not playing with a lot of memory that it needs to sort the array. So number of swaps is pretty less for selection sort. Let me go to the method selection sort where I have implemented the code to do the sorting. And before walking the code, this is my input array. In the first iteration it would try to get the minimum out of these elements. Which one is the minimum? So 1324. Now since we have found the first minimum, we would find the minimum between 3, 2 and 4 for the next iteration. And the following iteration, this would be the array which is already sorted. So that's the simple algorithm that is for selection sort. And the code that I have, it has an outer array loop on the input array, and in the inner loop I'm finding the minimum index. And once minimum index is found, that is the time when I'm doing swap. So, and that's the reason the number of swaps in selection sort is not very high. Whereas if you compare it to bubble sort, where you are comparing two elements and doing the swapping, so the swapping in that case would be higher in comparison to selection sort mechanism. So that's it really. And let me just debug it for you so that we can see it in action. So here the array that we have is 4321. This is the first iteration, and then you are going into the inner loop. You are comparing 4, which is AI is 4, AJ is 3, and then you are setting min index as j because 3 is less than 4. Then you are going for the next iteration in the inside loop. You are going to compare the 4 and 2, and again the min index would be set to the position of 2 because 2 is less than 4. Then you would compare 4 and 1. Again the min index is set to the position of element 1 because 1 is less than 4. Now the inner loop is finished. You checked whether min index is I, or not, which is it isn't, and then you swap 4 and 1. Now for the next iteration you have 1 3 2 4. Now you are going to compare the you will be finding the min between 3 2 and 4, and the min between 3 2 and 4 would be 2. So the min index is 2. Now you would be switching 3 and 2. The loop would still run, but it won't go into the min index, and that's it. So you got your sorted array back. Now you're just printing the results. So I hope you found the video useful. Do let me know if you have any questions, and stay tuned. I would be covering other sorting algorithms as well, like merge sort, quick sort, and comparing all the different sorts in my final video. Thank you.